Hi, and welcome to this week. And this week we are going to be looking at noise and interference. And in this first part of the lecture, what I want to do is just introduce the topic and talk about what noise is and what interference is. Now, of course, I don't think I really need to tell you what noise is. You have built some electronic circuits, and it would be fairly straightforward to you as to what that is. Let me give you a few examples to show what we are talking about. So in this slide, I have a variety of different kinds of noise that you would find in electronic circuits, right? So imagine that you have, let me just, so that's my pointer. So here's a signal. So this is the proper signal without any noise, without any interference. Okay. So you could have different kinds of noise and interference that are uh, that are impinging on this signal, right? So you could have something like so this noise here is just an offset noise. So instead of the signal being at zero, you have the offset added to it. But this offset sometimes may not be constant. It may be increasing, like in this case. Then you could call it offset, variable offset, but you could also call it drift, right? You could have a noise that is like some other frequency, a high frequency sinusoid impinging on this low frequency signal, like in this case. So probably the 50 hertz mains uh, 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 getting added on to the actual sine wave that you're measuring. You could have random noise, as in this case, uh, and sometimes if the random noise is quite a lot, then instead of, you may not actually see this measurement at all, and you may see a signal like this, right? So all these are kinds of noise and types of interference. So there's interference and noise mixed in here in these examples, which kind of um, uh, spoil your signal, or add something to your signal so that you cannot process it as you want. Okay, so let's then so that was just to give you an idea of what noise is, and now what I want to do is I want to kind of distinguish between noise and interference. So let's talk about the difference. So there is a very clear distinction between what noise is and what interference is. Okay, so interference is basically a result of an interaction between the circuit and the outside world. So if you have a circuit and there are electrical signals outside your circuit as well, and these electrical signals can in some way interact with your circuit, and because of that you may get certain things added on to the signal that you actually want. It may also happen that you can consider one part of your entire circuit to be what is of interest, and another part of your circuit could be interacting with this part in some way that you don't want it to. So that would be interference as well. Okay. Noise, on the other hand, is usually what we are talking about is internal sources. It is the circuit itself, the components itself that are producing uh, some kind of distortion in your signal. So, for example, if you have resistors, they have a random noise associated with it. Your op amps have some kind of noise associated with it, and so you pick up these noises, and while you amplify it and all, maybe this noise becomes very big. Does that make sense? Okay, so interference may or may not appear as a random signal. Okay, so for example, your power supply noise is not a random signal. It's a 50 hertz defined signal that adds on to the signal of interest. And usually you can reduce interference by laying out your circuit carefully. And by laying out, I mean uh, putting the circuit in a certain order. So you put certain components at one spot and other components on other spots. Maybe you run some lines which are grounded, and those kinds of operations actually can reduce interference. Noise, however, is usually appears as a random signal, and it cannot be reduced beyond a theoretical threshold. because all components have some noise associated with it, as I said, and you can't really reduce it. Okay, and thermal noise is one very, very common example of such noise. Thermal noise is present in resistors, and as you increase the temperature of resistors, you have larger and larger noise. And the way you reduce this noise is by circuit design and not by circuit layout. It doesn't matter how you put the components, because it's the components themselves that are generating the noise. You will have to design your circuit carefully. You will have to put certain, probably, filters and things of that kind to remove that noise or prevent that noise from affecting the signal that is of interest. Okay, hope that kind of gives you an idea of what noise and interference are, uh, and we'll take a deeper dive into these topics in the next few videos.